Welcome back to the Pool Pro Podcast. If you're using metal ion sanitizers or ionizers, you're going to want to listen to this episode of the Pool Pro Podcast, especially if you're experiencing staining. You'll have to find out why.
So welcome back to the Pool Pro Podcast. We're here with my partner,
Michelle. Hey, everybody.
And we're back with our Master Water Specialist, Greg Reyneke. We're continuing our series on alternative sanitizers. Supplemental sanitizers is probably a better way to say it.
Yep.
And I think the last one that we haven't touched on that I personally, again, would like to have an expert's opinion on and understand a little better is metal ion sanitizers. We want to talk about metals in the water. And so, Greg, what can you tell us about that? Now, one thing, you come out of the drinking water world a lot in waste treatment. So other than swimming pools, do metals have uses and benefits in other water treatment processes?
Yeah, they do. We use metals for Legionella control. Copper silver ionization is a very powerful tool for controlling Legionella in buildings. And of course, as we've seen the last few years, I believe the rate of Legionella contamination has grown 8-fold in the last 10 years.
Yeah.
And the new ASHRAE 188 standard, and then looking at ASSE's 12080 certification standard, there's a lot of concern with the proliferation of Legionella and other related bacteria. Now, when we look at Legionella from CDC numbers, if I recall correctly, something like 80% are related to recreational bodies of water, whether it's swimming pools or whether it's water features. And so there's significant usage of copper silver ions for that life critical application. Legionella remediation, typically when we run into a situation when a building has been diagnosed with Legionella, then we're looking to get rid of that Legionella and get down to 0 CFUs, colony forming units. And copper silver ionization technology works extremely well. In fact, better than chlorine in those applications. So if we look at the use of metals in water treatment, we can go back a long time. In fact, there's historical reference in Roman times to the use of copper and silver goblets for drinking. So I believe Pliny talked about the flavor of wine when poured from a copper cup. And then, of course, silver was recognized in medieval times as having some magical properties. And so we've always known that there's something going on between certain metals and bad stuff. And copper and silver are the two that seems to always come to the fore. And if we think of the old cowboy stories, the cowboy would put a silver dollar in his canteen and the water would stay fresh in the canteen longer. Well, it's true, because that little bit of silver dissolving into the water acted as a bacteriostatic. So there's probably 2 terms we should define: bacteriostatic and bactericidal. Bacteriostatic means it doesn't allow bacteria to grow. Bactericidal means it kills the bacteria that has grown. And that's an important distinction. So bacteriostatic is easier to do typically than bactericidal. So in drinking water applications, things like silver impregnated carbons are used in drinking filters to minimize biofilm growth and accumulation. Silver impregnated plastics are used to minimize biofilm accumulation in tubing. And then with copper, even good old copper pipe is recognized as being mildly bacteriostatic. You'll end up with less biofilm growing in the pipes. Now, when it comes to open bodies of water, For a long time, people have used various copper compounds to try to control algae, copper sulfate or chelated copper. They've been used successfully and unsuccessfully on ponds and things like that. And most of it comes down to not quite understanding the chemistry that you're working with. So when we're dealing with copper, for example, copper ions, and another definition, the ion is the smallest form that a chemical can take. So this copper ion that's dissolved in the water, it reacts with the cellular wall of the bacteria, and it interferes with the bacteria's ability to keep itself together. And so the bacteria can die. Now, interestingly enough, both with silver and with copper, the exact mechanisms have not been properly described because we lack the analytical technology to look at the kill happening. We just know that they kill. And so in the presence of enough copper, most bacteria will die. And in the presence of enough silver, most bacteria will die. The problem is what's enough? And then the second problem is what interferes with these metallic ions getting to the bacteria or to the algae body. So in a pond, for example, you have two complications. One is the ground, and the second is what you're trying not to kill. So typically there's fish in ponds, and people want to put copper into the pond to kill algae. The problem is certain fish, particularly the salmonids, trout, they are sensitive to copper. And so if the copper level is too high, your fish go belly up. And dead fish are a great source of phosphate and nitrate, which feeds algae, and they smell bad. So that's not good. In a pool, metals are used to control problem algae. You'll often see these chelated copper solutions that are pitched as ways to control black algae or yellow algae. In some areas, the chlorine does a great job getting rid of the green stuff, but then you'll see black slime accumulation or this yellowy algae accumulation. And so anecdotally, certain pool treatment professionals have had good success using various copper products to minimize the ability for those algae to grow. Your big complicating factor with anything metallic is calcium. The higher the calcium level, the less active that metal will be in the water because it's binding to the copper. So typically where we see failure is where somebody has applied a copper treatment and not taken the time to look at what the actual calcium concentration is.
So what kind of a threshold are we talking about for calcium hardness?
For what I'd like to see here, you probably don't want to get much above 300 milligrams per liter, which is problematic because a lot of pool people keep their calcium higher than that anyway. And then they try to stabilize that with pH. And then you end up with some interesting chemistry with the copper because copper sulfate, for example, is going to disassociate from the sulfate side. And some of your calcium that's in the water will then combine with the sulfate, and you'll end up with copper sulfate, calcium sulfate, which is a form of permanent hardness. And you might end up with a haze in the water. So you got to be really careful and not rely on it entirely. And then if you're using phosphates at all, for example, in some places, people will use phosphate treatments to control rust. If you're using phosphates, those phosphates will bind to your copper or your silver ions. So one way to overcome a lot of these issues is to use ion generators. And that's essentially an electrolysis process where you then are introducing metallic ions into the water using a DC power supply. And you're creating a corrosion cell, whether it's copper or silver, and you're letting those ions get in the water. Again, this goes back to so much of what we talk about. You're needing to use real science, not just hope and imagination. So typically what I see with these copper ionizers, they have a little block of copper, maybe 5-6 centimeters long, a half a centimeter thick, centimeter wide. And they're now deploying this in situ, and they're trying to add enough copper into the water to control algae in a 50,000 gallon pool. And when it comes down to copper and algae control, there is a good body of work that's been done. And we typically want to see copper levels between 0.5 and 4 parts per million. That's a lot of copper.
It is.
And when you think of the weight of 50,000 gallons of water, and then you think of the weight of copper required, you're going to be backing up a Brinks truck to carry all of those copper ingots to get the job done. And so again, it comes down to managing expectations. So where do we see best results with these little ionizers? Teeny tiny ponds, teeny tiny spas, teeny tiny water features, or controlled environments like plumbing. See, with plumbing, you can get away with a lot less copper because it's a sealed system. With a recreational body, whether it's a water feature or a pool or a pond, it's an open environment. It's constantly being contaminated. And so it requires a lot more killing power to get the job done. So which works better? It depends. Which one's cheaper? Copper. Which one's easier? Silver. So it's one of those interesting things.
And some
your
of the
mileage will vary.
Some of the ionizer units claim to utilize both copper and silver.
Yes.
And the way that you can tell a lot of times that a pool has the copper and silver is that the pool will be stained both blue and black.
Yep. Yep. And that's how you know that we've applied a good tool, but unfortunately in unbalanced chemistry. And that's one of the significant liabilities in a decorative pool or a residential pool with gunite, for example. Gunite contains calcium. That copper is going to want to stick to it. And unless you're really careful with your chemistry, you can end up with those streaks.
So pH is a huge factor. You've got to keep your pH, run your pH at a lower, which makes the water more aggressive, which makes me want to put more calcium into the water to help buffer. So I'm starting to see a problem here.
Yep, there's the problem. And so it's a different mindset. Now, I've seen some of these natural swim pool, the European, UK concept, where they've got the swim pool concept, where they've got biofiltration and a filtration bog. Mm. I've seen a few of them where they use chelated copper. So it's copper that's been exposed to glycine or another chelant. And that works really well at low levels, but you still end up with biofilm. So in a natural pool, a little biofilm on the bottom, nobody has a problem with it. In a smooth, nice, typical American pool, we got a problem with the slimy floor.
Yeah, we don't want
You're going to get that call.
So let me ask you this. We have charts that we can look at for ozone and chlorine in terms of the kill times for different pathogens. Does such a thing exist for metals?
Yes, to a degree. So on Legionella control, there's been a significant amount of research done, particularly because it's such a strong health concern. And then also on reservoir management, if you think about most towns in the US and around the world, the drinking water is captured and stored. And that water then has to be treated to meet primary drinking water regulations. And one of the biggest concerns is algae growth in the reservoir. So a lot of research has been done in controlling algae in reservoirs as a pre-treatment to drinking water. So this is a long answer to a short question, but I promise I'll give it to you here in a second.
Sure.
The US EPA and the USDA have published a lot of work on controlling algae at different chemistries, different hardness, different pH, and the effect that it has on the aquatic ecosystem, what it does to fish, what it does to mollusks and various things. And then there's been a lot of industry research on copper silver ionization. So the data's out there. A good manufacturer will supply you with the consensus data. And what the consensus data is just a combination of what everybody has learned in their research, erring on the side of caution. And there's two data points that a pool professional should hear. The first is contact time. Give an example, if the contact time for chlorine is X, contact time for silver is about 20X, and the contact time for copper is about 25 to 30X. So a lot more contact time is required because it's not an oxidizing killer. It's reacting in a different mechanism. It's kind of like when you're using quartz. They have a different kill mechanism than an oxidant. So you have a much longer contact time required. And then you have a lot of interference factors when it comes to the minerals. And a good vendor will be able to give you data on what they have seen or what they believe the interference factors will be at different pHs and different calcium saturation levels. Because there's a concentration curve. You know, at different pHs, you're going to see the copper take different states, and you're going to see the silver take on different states, and they'll have different levels of efficacy against living organisms.
So what I've heard the claim made by some chemists online that contribute to the forums that because of that CT value being so much higher with metals, that there really should not be looked at to protect against bather to bather transmission of pathogens. They're not really, they should not ever be used as a way of trying to get to a chlorine-free pool, which is how a lot of these units are sold.
I would concur with that. Absolutely. I can't even comprehend in a traditional swimming pool having somebody even think that it could be used in an alternative to chlorine. It is not.
My other question that I've always wondered about is, you've got all these metal ions in the water, and you have a powerful oxidizer like chlorine or ozone. What happens to those metal ions when they contact a really strong oxidizer?
Oxidation. So you knew that. So what happens is those metals then are oxidized typically into a non-dissolved state. And they will then now become a solid that precipitates out. And you're also burning up your ozone and or your chlorine. And so again, complicated chemistry. Why would you want to add copper that's going to consume your chlorine, that's going to raise your chlorine demand? Or why would you want to add copper that's going to raise your ozone demand? Now, there's certain times, certain spot treatments, you know, a few of the companies I've worked with in Florida, some in Oklahoma, I've seen where they have phenomenal results, temporarily treating with chelated copper to address a problem algae. They don't have the ability to drain and scrub and clean the pool, so they hit it with a chelated copper treatment, problem goes away. But then they spend a month fixing the chemistry. And so, you know, it's like everything. There's a balance, and there's nothing for free.
And I see that too, that you get into this merry-go-round that's very hard to get off of, because
Exactly.
you have the metal, the oxidized metals in the water. So the first thing you do is go down to the pool supply house and buy a sequestering agent or a stain treatment, which is phosphate based,
Yep.
which you just explained very clearly to us. So you're spinning in circles, I think.
And phosphate's food for algae. So now you're compounding your issue with any algal bodies that are still alive in the pool. I mean, you're going to chase your tail.
Right. By adding the algae food, you're negating the algae killing properties of the metals. So
makes your job harder.
Yeah.
For us, when we treat algae industrially at the wastewater level or decorative and wastewater and ponds and pools and things, we're always trying to get rid of the phosphates. We try to starve the algae, get rid of the phosphates, find a way to change the nitrates so that you can get away with less active disinfectant because it's harder for the algae to grow. They're starving to death. And so there's so many things you can do wrong when you start adding sequestrants and stain control and everything else. It gets out of hand real fast.
Yeah, and I've seen more pools than not. What generally happens is a pool professional will inherit a pool that has this on it. Fortunately, by the time they inherit it, it's usually out of commission. It's been disabled, and it's just $1,500 down the drain for the homeowner. But in some cases, they're still working, and the pools, it's very rare that you see a pool with an ionization system that doesn't have staining on the plaster.
I agree.
So, well, I just wanted to add this discussion in too, because it is something that we walk the trade show floor and walk past a booth, and there's this machine, and it's promoted as again, it's a lot of times these are sold as chlorine replacements, chlorine alternatives. You can get to a chlorine pool. I know there's a number of pools in Los Angeles that were sold as chlorine-free pools that have a really big, powerful ozone system on them and an ionizer. And it just seems to be, to me, you've really confirmed what I've kind of felt all along. That's really not the best combination. I think you're just as well to save your money and go big with a nice ozone system and put a chlorine dosing and pH control system along with your ozone, and you'll get so much better water.
I agree 100%. And not to overlook the importance of good filtration. And with some of the new filtration sands that are out there now that have active disinfectants impregnated onto them, there's a whole new avenue for a pool treatment professional. Things that we've been using for cooling towers and wastewater that are now finding their way into the pool world, where you have a sand that's not just physically capturing, but it actually kills. And so we're going to see a lot more of these newer technologies used that are easier to deploy, that are not creating weird chemistry downstream.
So by these filter medias, you're talking about sand filter medias, obviously.
Yes.
And you're talking with things like activated glass media.
Media that's treated with a lysing agent. So picture microban for pools.
Okay.
Yeah, that's the next big thing that I see coming down the pike, and that's going to really change the dynamics of recreational pool management, particularly at the small scale, because you can do so much more with your filter.
Yeah, and that's a discussion that we've had before. We've talked with James Ambergy from the University in Carolina, and who studies this extensively and speaks every year at the World Aquatic Health Conference. But that's his biggest contention, is that's the area that we are the farthest behind in terms of our technology here in this country.
Agreed.
Is filtration. And so basically using things like ozone and other things that are microflocculent to help our filters work better,
Yeah.
we're basically having to compensate for the fact that our filters don't work as well as they could.
Right.
That's exactly right. And it's so hard to balance cost versus performance. You
Yeah.
know, in my day job where I'm treating things that are a little more mission critical, cost is more flexible.
Yeah.
Yes.
And we can put in something that costs a lot more money than something going in a pool. And so
Yeah.
the filtration side of pools, when it comes to the media itself, the technologies for backwash, the technologies for self-cleaning, they've unfortunately been put on the back burner because
Yeah.
chlorine really hid a multitude of sins,
Yeah.
because you could just over chlorinate and you'd be in good shape a lot of the time. But in today's
Yes.
world of efficiency, environmental sensitivity, and our new understanding of the health impact of the things that you and I grew up swimming in, and now that we understand what that's doing, and most importantly, what our customers understand and what
Yeah.
their expectations are,
Yes.
this is going to be a big part of the pool treatment future, is making sure that the infrastructure for filtration is significantly more advanced.
And the problem with sand filters is just the size of them. To really get the proper filter flow rate, you want it as slow as possible so that water percolates and really gives the filter media a chance to grab things. That filter's got to be so much bigger than a cartridge or a standard
Exactly.
DE filter, and
Exactly.
um, that's the the biggest thing. I've become more and more of a fan of sand filters with the right media in them, but they are a lot of work when it comes to maintaining them and changing the sand, getting them started up, getting that sand in there and handling it right. And they're big.
They are. So a good place to take a page from is, again, on our side of the fence, treating cooling towers. A cooling tower is basically a nasty pool. You know, it's got bird poop in it, and it's got everything else that ends up in it, and it's used to control temperature. And so a lot of the techniques have been tested and advanced there when it comes
Mhm.
to auto ORP feeds, auto pH feeds, and then high efficiency side stream filtration, things like that. So I think you're going to see more of a crossover between our industries. And as people on the pool side, progressive guys like you, are learning more, there's so much that you can take that's already been done
Mm-hmm.
in other complementary fields.
Yeah. And then who really needs to take note of that, in my estimation, is the engineers at the major manufacturers.
Yes.
I mean, I've been in the business 32 years, and basically the filters that are available that I'm selling now are the filters pretty close, at least the guts inside. Maybe the outside tank has changed a little bit, but it's the same technology and the same exact science that I had to offer people when I started 32 years ago. And I think um, it really comes down to the manufacturers seeing the need and
Yep.
wanting to start engineering a better product.
Agreed. The demand has to come from the consumer and the pool professional.
Yes.
The same stuff from 30 years ago is still in use today. And I'd say the only difference is it's not built as well as it used to be.
Right.
Sooner.
Yeah.
Yes, we don't
Exactly.
have stainless steel tanks anymore. It's plastic.
Exactly.
The sun tears them up, and you got to replace the tank cover
Yeah,
every 3 years.
yeah.
But yeah, so the I would love to advocate for more than just cosmetic changes to the outside of the tank. Let's look at the guts and let's see if we can't
Yeah.
make it work better.
Yeah, and the heart of it is what you use for sand or what you use for a cartridge. And
Yeah.
there's more options than just what the guy at the pool store has. And so it's good for a professional to research. And again, complementary industries. There's things we're doing in the industrial and the commercial, residential, potable water side that really will translate to the pool side. And even things from the wastewater side or the cooling tower, or the stormwater side that translate to the pool side. Because at the end of the day, we're all trying to do the same thing. We're trying to balance chemistry. We're trying to catch cooties, and we're trying to keep the bad bugs dead.
Yeah.
Yeah, exactly. I don't know why James Ambry doesn't come out with his own filter, Dave. He could probably make a lot of money on it. He said he's already invented one. He just needs to put it to market and manufacture it.
Waiting for somebody to
give him the money.
Cough up the dough.
Yes. I hear you.
If I had it, I'd do it, but I don't. So
I know, me too. Perfect.
Well, Greg, this is great.
Yeah.
I think I hope we've given our listeners a much more comprehensive understanding of these technologies: ozone, UV, AOP, metals.
Yep.
So that we can think about how we want to use them, if we want to use them, and what understanding the tools and understanding their limitations and requirements, and what we're going to have to know once we install these things to make them work the best way they can. This has been huge. I can't thank you enough for your time, and what you've shared with us here is terrific stuff.
It's my pleasure. It's a lot of fun talking to people who are advancing the art of their industry, and keep encouraging more pool professionals to learn more.
Yes, absolutely.
That's how we all get better. We have to keep learning.
That's true.
It is so true. Thanks so much, Greg. We appreciate you.
Thanks again. Thanks again. Appreciate your time.
Absolutely.
A new voice in the industry, a resource for all, education for you. This is Pool Pro Podcast. Build relationships and share important news as we get ready for our next backyard adventure. Pool Pro Podcast. Backyard adventures are better together. Please take a moment to share, like, and review our content with all of those that would be interested.